Next, we will analyze the functionality of the application, for simplicity making reference to an example of a plane frame, though the program can be applied to any model, even a three-dimensional one. In the Properties Reinforced Concrete menu, you can define reinforcement properties and materials that, in analogy to what is done in Strand 7, can then be applied to the beam elements. In particular, it is possible to define properties characterized by reinforcement in which the user can define the possible positions of the bars inside the section and the geometry of the stirrups, such as polygonal stirrups, omega stirrups, hooks, and secular stirrups for secular sections. In the Materials menu, the properties of concrete and rebar are defined, specifying, for example, whether it is a new or existing material. In the latter case, the mean values of strength obtained from in situ tests and from the additional sources of information on the building must be provided, together with the values of the material partial factors, depending on the level of knowledge achieved. In the Attributes Reinforced Concrete menu, you can apply the reinforcement properties previously defined to the beam elements and beam column joints. In the Settings General menu, you can define settings such as the number of the reference node to be used to calculate the capacity curves of the building, settings related to nonlinear analysis, which the program performs interfacing with Strand 7, project data related to site seismicity, and the parameters to be used for the verification of structural members. The reference standard, Italian NTC 2008 or EC8, the formula, analytical or experimental, used to calculate the total chord rotation capacity of the elements, the reference limit states, collapse, severe damage or limited damage, and finally, the possibility of considering or not the efficiency of the confinement of the stirrups. We know, in fact, that when the stirrups do not present the closure with 135-degree hooks, legislation considers now the confinement effectiveness factor alpha present in the formulas of verification. Finally, you can define the values of the combination factors psi 0 and psi 2 for the load cases defined in the Strand 7 model. Now let's see the example in question, relating to an existing building. We apply a property reinforcement defined for the columns. It is necessary to define the length of the portion to be reinforced, e.g. 80 cm, and check the bars and stirrups of the property that you actually want to insert in the element, with the relative sizes, bar diameters and spacing of stirrups. In this way, you can use the same property for more reinforcement combinations, such as defining a greater or lesser amount and type of reinforcement in the beam intraders or in the beam extraders, or different transverse reinforcement. When you arrive at the top end of a column, the program shows a window to define the reinforcement of a beam column joint. In the Calculation menu, you can define the criterion used to bilinearize the capacity curves and the load distributions to apply to the building. Once you have made the appropriate choices, you can start the calculation of plastic hinges N, M1, M2. After the calculation of plastic hinges, you can start the calculation of the load distributions and the nonlinear analysis. Finally, it is possible to perform the calculation of the seismic demand. The parameters of the 1 degree of freedom equivalent elementary elastoplastic oscillator and the maximum displacement of the reference point are presented, the latter depending on the elastic design response spectrum. In the Results menu, you can examine the moment curvature diagrams created in the Strand 7 properties by EasyOver. These diagrams are the result of the reinforcement entered by the user and the actions on the beam, namely normal force and the ratio of bending moments. In any reinforced element, you can check, for example, the influence of the normal force on the strength and ductility. Still, in the Results menu, you can view the results of the element verifications. On selecting one of the nonlinear analyses just solved, for each load increment, the reference point displacement is shown. You can view the deformed shape of the structure and the graphical report of the verification of the ductile elements, i.e. in terms of chord rotation, and the verification of the fragile elements, namely shear verification in beams and in beam column joints. The available models for shear verification are, for new buildings, the variable strut inclination truss model. For existing buildings, the model proposed by Biskinis et al., used in Eurocode 8 Part 3, and the model with both the classical 45-degree truss model and a concrete contribution at most equal to the contribution of the elements without a transverse reinforcement, as stated in the Italian circular number 617 of the 2nd of February 2009. Finally, the program automatically provides a calculation report in Word format, with the definition of the reinforcement entered, the calculated parameters of the capacity curves, and the verifications carried out. The verifications with negative results are highlighted in bold. All calculations made by the program are made available to the user on Strand 7 models generated from the main model, so the user can check the different steps of the analysis up to the final verifications, thus having full control of the situation. The strength of this solution is that users can exploit the enormous potential of a program like Strand 7, which has no limit to the applications, while automating the pre- and post-processing operations necessary for nonlinear analysis of new and existing buildings. Future developments are adaptive pushover, with the update of the modes of the structure and thus of the load distribution, depending on the actual stiffness of each element at each step of loading. A module for steel structures, with the design of welded and bolted connections according to Eurocode 3. A module for composite structures in steel concrete, and the interface with the well-known three-dimensional BIM software, Tekla Structures. Goodbye to the next video. For information, write to studiodisciascio@gmail.com or visit our Facebook page. The website disciasciosrl.com, currently being updated, will soon be available.